straightforward design intended for practical use. This bus stop was located near the Pusat Islam and Al-Muslim Mosque at the Sultan Azlan Shah, which is the new campus for the University Pendidikan Sultan Idris. There are 3 bus near there. It design area where the students, staff or community can wait for bus to arrive and depart to the class, college and faculty. It also connects the campus to off-campus for the student who lives outside the campus. It usually has sitting place and covered waiting room, giving comfort and convenience for the users as they wait for the bus. This bus stop has simple features and a small rectangular design structure. It has a flat, slanted roof supported by triangular and prism poles. The total area of this bus stop is 18,750 cm square. It has a round shape, right triangle form, square, and the last one is rectangular prism.
Hi there, I'm ASISIA RAMONIA Anak Arrangement. My student ID is 2022-105-311. Here, I would like to explain more about the geometry, shape, and bus stop of Al-Mushiddin Mosque. First thing first, what did you know about geometry? Geometry is the branch of mathematics that deal with shape, angle, dimension, and size of variety of things that we see in daily life. The same goes to the bus stop of Al-Mushiddin Mosque, where this bus stop has a few geometry shapes such as circle, square, right triangle, and so on. Don't worry, I will show you which part of this bus stop has this geometry shape. First, as you can see, the wall of this bus stop is designed in a circle shape. Then the other side of the wall also has a right triangle shape. The floor of this bus stop also have a square shape, and the last one, the floor of the bus stop shape rectangular prism. We are now proceeding to the geometry concept. In this subtopic, the idea of the end object geometry, curve, shape, and measurement will be learned based on our chosen building, which is the mosque bus stop. The first step is a circle. A circle is a closed two-dimensional object in which the collision of all points in the plane is equally spaced from the center. The radius of a circle is the length measured from its center to its outermost line. The diameter, which is equal to twice the radius, is the line that splits a circle in half. To calculate the area of a circle, we see the total area that the circle occupies. We use the area of circle formula, which is pi r square, where pi is equal to 3.115, and r here is equal to its radius. For example, here we have the diameter of a circle from the mosque bus stop, 4,000 centimeters. So, using the formula 3.1415 multiplied by 4,000 square is equal to 113.094 times power 10 of 6 centimeter square. That's all.
The second one is right triangle. A triangle is said to be right angle triangle if any one of its interior angle is equal to 90 degrees. To calculate the area of right angle triangle, we use the formula 1/2 multiplied with base times length. Here, using the measurement of right angle triangle wall, 1/2 multiplied by 4800 cm times 25,000 cm, we get 60 times 10 power of 6 cm square. The third shape is a square. A square is a two-dimensional shape in the plane that has 4 angles that sum up to 90 degrees and 4 equal sides. For this shape, we will calculate the perimeter and the area of the square. The square's perimeter is equal to the sum of its 4 sides. the square side's length is still measured in the same unit as the perimeter, such as side plus side plus side plus side. For example, 3000 centimeter plus 3000 centimeter plus 3000 centimeter plus 3000 centimeter, and we get 12,000 centimeter. The area is equal to side square, or the square of the sides. The unit of measurement is square. Area equals to side times side. For example, 3000 times 3000 equals to 9,000 centimeters square. And the last one is rectangular prism, which is known as a cuboid, sometimes because of its shape. Rectangular prisms are polyhedron with two parallel and congruent bases. To calculate the volume, cubic units are used to represent the volume of a rectangular prism. It is also defined as the number of units used to fill the rectangular prism. A rectangular prism's volume is determined by multiplying its height and the area of its base. The volume of a rectangular prism equals to length times width times height in cubic units. For example, 3300 centimeter times 2400 centimeter times 25200 centimeter equals to 1.99584 times 10 power of 11 centimeter cubic.
Today, I would like to present about a transformation in mathematics. As we know, transformation have four types, which is translation, rotation, reflection, and dilation. We will go with the first transformation, which is translation. Translation will move each point of the object with certain distance or direction. This transformation will not change the shape or the properties of the object. As example, we can see point A prime, B prime, and C prime is an image for object ABC that transforms with translation. The second transformation is a rotation. Rotation is a transformation that uses angles to change the position of the object. It can be done in both directions, which is clockwise and counterclockwise, with certain angle and center point. For example, object ABC has done rotation with 19 degrees counterclockwise to produce image A prime, B prime, and C prime. The third transformation is reflection. Reflection is a process which moves each point, use concept of mirror of shadow. Transformation will change the orientation of the object, but still keep the size and the shape of the object. As example, object A has done reflection with a light segment that produce image A prime. The last one is dilation. Dilation changes the size of the object to transformation. The size will change to enlarge or decrease, refer to scale and point. As example, object A has transformed to image A prime with dilation at point K that make the size of the image is large than object. In this case, which is transformation in motif and pattern, we will go through with the first transformation, which is transformation in motif. The first transformation is reflection in motif. Figure 1. The top of the bars use reflection as a motif. This reflection will use same size and shape of the object used for each image that has been produced. Figure 2 shows how the transform reflection used in this motif. A line segment used as a mirror that can pass the shadow. We can see object W, X, Y, Z, and image W prime, X prime, Y prime, Z prime has been transformed with reflection. The second transformation is dilation in motif. Figure 3, the rectangle motif at the foot of the bus seat has been transformed by dilation. The size of the object changed according to the scale and specific points. As we can see, figure 4 shows the details how can object A, B, C, D dilation to image A prime, B prime, C prime, and D prime. Image A prime, B prime, C prime, and D prime has a big size than the original object. We move to the next transformation, which is transformation in patterns. The transformation is translation in patterns. Figure 5 and 6 show how the square and rectangle patterns that involve in transformation on translation. This transformation will move every point of the object without changing the shape or properties. Translation make the object can be moved up, down, left, and right as an image in one or more unit to form square and rectangle. The pattern of squares and rectangles can be seen on the top and the floor bus stop.
Next, I will present the summary for our assignment. In summary, we know that there are various geometrical shapes that can be found around us. In this assignment, we are choosing the bus stop of Al-Murshidin Mosque. It is the place where students or visitors use a car-hailing service waiting to be picked up by the driver and rest while waiting for the next bus. Circle, right angle, square and rectangular prism are the shapes that can be found at the bus stop. Each of the shapes has its own unique perimeter, areas, volume, lengths, and angles. We were able to classify the shapes as either 2-dimension or 3-dimension. In addition, the transformation that is contained in this bus stop are reflection, dilation, and translation. Last but not least, the conclusion of this assignment. In conclusion, this assignment has taught us the topic geometry in mathematics, which is the branch of mathematics that deals with most things in our environment. However, some people are unaware of the practical application of geometric mathematics outside of the classroom. In addition to learning new material, we can review that we have already learned from earlier classes. We discovered that geometry is relevant to a wide range of topics by working on this assignment. Other than that, because we are in various courses, we learn how to converse with one another. We also discover the value of working as a team, which requires that we consult and identify an item that we call easily measured. Not to mention, this task taught us a great deal of new information that we can use as an application in the future.